Hello and welcome to a special Fall 2024 UIL edition of Champion Brief's video topic analysis series. I'm Daniel Shatzkin, the editor-in-chief of Champion Brief's Lincoln Douglas Brief, and today we will discuss the topic resolved in the United States, agroecology ought to be prioritized over industrial agriculture. In addressing the topic, I will talk about one of the most pressing issues facing humanity, how we produce and consume food. With a growing global population, climate change, and increasing resource constraints, we must reevaluate how our agricultural system functions. Agroecology offers a promising pathway to not only feed the world, but to do so in a way that may be sustainable, equitable, and respectful of the environment. I'll be comparing agroecology with industrial agriculture to show how these systems differ in their impacts on the environment, social structures, and economy. We'll also explore concepts such as agroforestry, a key component of agroecology, and the role of concentrated animal feeding operations, or CAFOs. By the end of this discussion, I hope to show you not only some of the promise of agroecology, but also several of its problems. Let's first begin by asking, what is agroecology? Agroecology generally presents significant advantages in terms of environmental sustainability, focusing on practices that enhance biodiversity, soil health, and ecological balance. Techniques such as crop rotation, polycultures, and organic inputs work with natural processes to reduce the reliance on chemical fertilizers and pesticides. This approach fosters healthier ecosystems, improves resilience to climate change, and promotes long-term soil fertility. However, these benefits come with challenges, particularly in terms of productivity and scalability. When compared to industrial agriculture, agroecology often struggles with lower yields. Industrial agriculture relies on high-yielding monocultures or single crops, advanced machinery, and synthetic inputs to maximize productivity and efficiency. This system is designed to meet the high demands of growing global population and to stabilize food prices through economies of scale. In contrast, agroecological methods, while sustainable, may not produce food at the same scale or speed, which can be a significant drawback in regions where food security is a pressing issue. Moreover, the United States' role within the global food system makes a demand for agroecological processes a stress on the entire global food production system. Agroecology can also require more labor and expertise compared to industrial agriculture. The intensive nature of agroecological practices demands a thorough understanding of local ecosystems, diverse crop management, and constant monitoring. This can be particularly challenging for smallholder farmers who may lack the access to necessary resources, education, industrial or education that agroecological systems require. Industrial agriculture benefits from mechanization and a standardized process, which streamlines the production and reduces the need for manual labor. The complexity and labor intensity of agroecology can generally be a barrier to its broader adoption, but we're going to talk more on that in a little while. Socially, agroecology emphasizes local knowledge and community involvement, which can enhance social equity by empowering smallholder farmers and promoting fairer food systems. For example, pig farms in North Carolina have historically been built on low-income land that is predominantly where minority populations in North Carolina live. These farms offer their own challenges, which we'll discuss a little bit more during the section when we discuss CAFOs, but these types of industrial farming practices were putting some of the worst types of industrial farms in terms of the environment in some of the lowest income areas are things that agroecology tries to address. However, it also faces its own economic challenges. Generally, the initial investment required for agroecological practices is very high, and the financial returns can be slower to industrial agriculture's more immediate and large-scale outputs. While agroecology does aim to create more equitable and resilient food systems, the practical barriers related to productivity and economic viability can limit its impact on widespread adoption, particularly in regions heavily reliant on industrial methods like the United States. So now that we understand a little bit about what agroecology is, what it tries to do, and what some of the harms of it are, let's go into it more in depth, starting with soil health. Soil health is fundamental to agroecology. Soil is like a living ecosystem, right? It's teeming with all these little microorganisms that are essential for plant growth. In industrial agriculture, the heavy machinery and the chemical inputs like fertilizers and pesticides degrade the soil. It compacts it and it kills the beneficial organisms. Agroecology, on the other hand, generally focuses on practices that improve soil structure and promotes life below the surface. For example, cover cropping, where a non-harvested crop is planted to cover the soil, which prevents erosion. And then as the crop dies, it enhances soil organic matter and supports biodiversity that way. Healthy soil generally is not only more productive, but it also can act as a carbon sink by capturing carbon dioxide from the atmosphere, which then helps mitigate climate change. Agroecology's emphasis on soil conservation contrasts sharply with the industrial agricultural practices. Their focus is often on short-term yield maximization, heavy plowing, monoculture planting, so one crop, and chemical treatments have led to widespread soil degradation and desertification in many parts of the world. According to the United Nations, globally, we lose around 24 billion tons of fertile soil each year due to unsustainable agricultural practices. This is a crisis we cannot afford to ignore, and with many countries modeling the United States agricultural practices, this is a way potentially to help slow the loss of the billions of tons of fertile soil that occur each year. Agroecology also offers these solutions by prioritizing the long-term soil health over immediate profits. It functionally concedes that there will be less profits in the short term in the agriculture industry. But one of the most compelling reasons that I found to adopt agroecological practices is the potential to build resilience against climate change. Industrial agriculture is a significant contributor to greenhouse gas emissions, responsible for up to one-third of global emissions, mainly through deforestation, livestock production, and the use of synthetic fertilizers. Conversely, though, agroecology does reduce emissions by relying less on fossil fuels and those synthetic inputs like fertilizers, and by promoting carbon sequestration through practices like agroforestry and organic farming and those soil regenerative practices that I talked about just a second ago. Agroecological systems are inherently more adaptable to climate change conditions. By fostering biodiversity, these systems can better withstand weather events like floods and droughts and heat waves. When you have like trees and stuff in on the ground and you're constantly putting different crops in there and keeping the soil healthy, it's less likely to blow away like what happened during the Dust Bowl of the early 1900s and stuff like that. So crop diversity can help ensure that if one crop fails due to an adverse weather, others might still succeed, providing a buffer against a total loss for a small farm. In contrast, monoculture systems can be incredibly vulnerable. If the single crop fails, the entire harvest is lost, which leads to them doing some practices like fertilizers and pesticides, which we'll talk more about in a moment, that can be very harmful. Given the growing unpredictability of our current climate and, just heat waves and weird weather, rain events and late freezes and all sorts of stuff that's happening, resilience is key to ensuring the overall global food security and food chain. But let's take a look at industrial agriculture for their short-term gains with the long-term costs, right? There's no denying that industrial agriculture has achieved some remarkable short-term gains in food production, and that global food security is significantly better than it was even 100 years ago. Through mechanization, the use of synthetic chemicals, high yield crop varieties, we've been able to produce mass quantities of food that's feeding billions of people on a scale that has never been seen before in human history. The green revolution of the 20th century, with its focus on maximizing outputs, helped alleviate hunger in so many parts of the world. But that doesn't mean the problem was solved. And moreover, the approach has come with significant environmental and social costs. One of the major problems of industrial agriculture is the reliance on monocultures, like I said. That monoculture farming strips the land of biodiversity, making it super, super, super vulnerable to things like pests and disease. To combat these threats, farmers use a lot of pesticides and herbicides, which I said, and those end up contaminating water supplies, they harm wildlife, and they also contribute a lot to human health problems. And when there's increased phosphates in the ground and there's increased fertilizers getting into the water system, that all contributes to human health. When there's increased antibiotics going into livestock to help prevent diseases, all of that affects human health in the long term by contributing to things like antibiotic resistance. So these chemicals, will beneficial because they can, preserve the crop against pests and diseases, also harm humans. But moreover, they harm bees and butterflies, the chief pollinators in the natural world. There are many studies out there that say that if bees and butterflies stop their pollinating actions, that basically stops the function of the entire food chain, because they are critical to the growth seasons of all sorts of life. And honestly, it's one of the biggest impacts, and there's a lot of evidence out there for it, because pollination is just critical to the overall health of the entire ecosystem. Moreover, industrial agriculture can be incredibly energy intensive. Heavy machinery takes a lot of fuel to run. While there are pushes for things like electric tractors, the move is just not there yet, and the technology is not there yet to do it at scale. The production of synthetic fertilizers is heavily energy dependent and often requires the growth of specific crops like ethanol or corn to produce ethanol and stuff for fuel. And that's just being made for fuel. So whole fields just for fuel. This ultimately can contribute to climate change, and it will increase the overall carbon footprint of our food system. Well, it is true that industrial agriculture can produce food at a lower cost. That cannot be denied. These externalized environmental and social costs are generally not reflected in the price of food. The long-term degradation of our overall ecosystem and the depletion of natural resources and the contribution of climate change are all going to be far more costly in the future. And that means the price of food, which is already incredibly high in this country, is just going to keep going up unless we start to introduce more sustainable practices that can be more resilient to the climate that we are living in. There's also a social and economic cost of industrial agriculture. Remember those pig farms that I mentioned earlier. There is a history of industrial agriculture coming in and buying out small farmers. And it's really a large issue within society. One of the lesser discussed but really important benefits of agroecology is its potential to address some of those social and economic inequalities that exist within the agriculture sector. Industrial agriculture really concentrates wealth often in the hands of large agribusinesses. Think Monsanto and Del Monte, often at the expense generally of a small scale, smallholder farm and small scale farms. In many parts of the world, including in the United States, small farmers are forced to compete with large scale operations that can produce food cheaper and in a larger amount. And they just can't compete. This often drives small farmers out of the business entirely, resulting in a loss of livelihood, cultural practices, and just the death of rural communities around this country. Agroecology, on the other hand, tries to empower these small scale farmers by promoting diversified, locally adapted farming systems. It values local knowledge and practices, helping farmers make the most of their specific environment and their conditions. Additionally, agroecology tries to support things like fair trade and cooperative models, which allow farmers to get better prices for their products by cutting out middlemen and creating more direct relationships with the consumers themselves. This sounds really nice, but sometimes this has some scalability problems. Food sovereignty, though, is a key thing when it comes to promoting food security as well. Because by promoting food sovereignty, where the communities have control over their food production, agroecology helps to create a more equitable food system. So no longer is a farmer necessarily growing food for a global food production system, but they're growing it for a local system. And this is really important where industrial agriculture has pushed farmers to the margins, where things like farmers markets are the only way for small scale farmers to even sell their goods at reasonable prices to keep them in business. Instead of being able to reach the masses through selling direct to groceries, stores, and all sorts of stuff that agribusiness has shut out small farmers from. Agroecology's focus on this local market and diversified crops can really strengthen rural economies, but also reduce dependence on some of those volatile global markets. For example, I know that I get peaches here in Colorado from Palisade, Colorado, and I love my Palisade, Colorado peaches, and I don't have to necessarily rely on a global market for those types of things. But at the same time, if I want citrus here, I have to rely on getting citrus from a wide variety of places that may be having issues. This local kind of farming market that can guarantee some local fresh produce versus a volatile global market can become a much bigger issue as climate change further changes how we grow our food. One of the kind of promising aspects that agroecology promotes is a system called agroforestry. It's a land management system that tries to integrate like trees and shrubs into the agricultural landscape along crops and livestock. This practice offers a lot of environmental benefits, including enhanced soil fertility and improved water retention and reduced erosion. Trees and agroforestry help basically the entire environment, and they cycle the nutrients back into the soil and act as these windbreaks to prevent giant windstorms from blowing down crops, and ultimately they protect crops from damage and the soil from damage and erosion. Moreover, agroforestry contributes significantly to climate change mitigation by sequestering carbon. Trees absorb carbon dioxide and release oxygen. The trees that capture carbon dioxide from that atmosphere store it in their biomass and they use it. It's fuel for them to grow, helping essentially to offset the carbon emissions from other agricultural activities. In addition to environmental benefits, agroforestry can also provide farmers with additional income streams. Trees produce timber, fruit, nuts, all sorts of other products that can be sold or used within the household for improving both economic sustainability and food security. Agroforestry also supports biodiversity in the environment because it creates habitats for wildlife and promotes things like natural pest control. Small animals like squirrels and birds eat bugs. They help prevent bugs from coming into that area. these natural pest controls are definitely probably are better than some of the chemical ones when it comes to human health. And ultimately, in this system with a more diversified landscape with trees and crops and livestock stock all interacting in a way that mimics a natural ecosystem, the diversity that makes that system ultimately makes it more resilient. Because if one crop in a system fails or suddenly one bird is missing in a system, there are other species to take its place and help balance out the ecosystem when there are massive environmental changes. And really, they become less reliant on things like fertilizer and pesticides because you're promoting a natural environment in which those things are taken care of naturally. There are challenges, though, to agroforestry. Establishing agroforestry is a significant requires rather a significant investment in labor and also just land management knowledge and time in land management. It also takes time for those trees to mature and provide economic returns. You know, you're not planting an apple tree and getting apples in a season. For small farmers with limited resources, that's going to be a big financial burden. Additionally, poorly planned agroforestry systems can cause competition with crops for water and nutrients, and they can also end up harming not only yield, but lead to increased deforestation. Careful planning and support are essential for a long-term success of agroforestry. But agroforestry leads me to transition to another problem within current industrial agriculture, and that's CAFOs, or concentrated animal feeding operation. No discussion of industrial agriculture would be complete without discussing the issue of CAFOs, and there are a lot, and I'm probably going to even leave a few out. Generally, these facilities house thousands, sometimes tens of thousands of animals in very confined spaces. CAFOs are designed to produce large quantities of meat, dairy, and eggs efficiently and cheaply, but they come with severe environmental, ethical, and human health costs. CAFOs generally generate massive amounts of waste, which can overwhelm local ecosystems. And the manure runoff from these operations contaminate water with nitrates, phosphates, and pathogens, leading to water pollution, algal blooms, and dead zones where aquatic life can't survive. CAFOs also produce significant quantities of methane, a potent greenhouse gas that contributes a lot to climate change. Agroecology. Oh, moreover, CAFOs can also lead to disease spread. The idea of concentrating animals closer together allows disease to spread more between those animals. Issues like bird flu going right now throughout chicken farms in this country are one example of it. Many people believe that some of COVID's origins are connected to the idea of concentrated animal feeding operations and the housing of animals together in mass quantities, which allows for diseases to spread, mutate, and potentially have what's called zoonotic spread, or the spread from an animal to a human. And the more that this happens, the more likely it is that humans are going to develop some sort of resistance to that disease. CAFOs are also a prominent promoter of antibiotics in their animals, and that antibiotics use in animals does lead to increased antibiotic resistance in humans because some of the same diseases that they're trying to stop with the antibiotics for animals are also present in humans. And so CAFOs present a massive problem within for disease spread within both the animal populations and humans. Just look at what happened over the last 6 months, where there were several dozen large-scale chicken kill-offs due to bird flu in chicken farms. There were issues with swine flu previously. So zoonotic spread within CAFOs is definitely a problem. Agroecology supposedly offers a more balanced and regenerative approach to animal husbandry. In agroecological systems, animals are often integrated with crop production, so they can provide natural fertilizer in the form of manure, and they also can help control pests through things like grazing. There are also aquaculture systems which combine both, farming practices with fish farms in order to use some of the off the off uh what's the word I'm looking for? The offsets and stuff, or not offsets, but the output from some of that farm to then grow fish and things like that. And these systems generally emphasize both animal welfare and will also avoiding environmental damage that is associated with the industrial scale animal farming. Some of those techniques also include things like rotational grazing, so that animals move through different pastures, which can improve soil health and help to increase carbon sequestration through soil health. Um, well, agroecology can be praised for its sustainability, biodiversity, and equitable food systems. It is, however, important to recognize that this approach is not without challenges. While agroecology offers many benefits, there are several potential downsides that could limit its widespread adoption. I've talked about them briefly, but let's go back over 5 of them that I think are really important. First is lower yields compared to industrial agriculture. It's one of the main criticisms of agroecology, and that intensive large-scale farming methods really have been designed to maximize output, often through the use of high-yield crop varieties, chemical inputs, and mechanization. Agroecological systems promote biodiversity and long-term soil health, but they're not really as efficient in producing high volumes of food in the short term. With a growing global population, increased food prices already, there are concerns that if we prioritize agroecology, we may not be able to produce enough food to meet a global demand, especially when there are regions that are already facing mass food insecurity and there are already food deserts within the United States. Second is the requisite for more labor and knowledge about the land. Agroecology is incredibly labor intensive, and it requires a deeper understanding of ecological systems than industrial farming. Just farmers need to have a knowledge of local ecosystems, crop rotations, polycultures, which plants work best with which plants, which trees work best with which crops, organic pest management practices, better organic animal husbandry practices, the concept of growing crops alongside different animals. Understanding all of these practices makes agroecology really complex and time consuming. In many regions where there's already a labor scarcity, or it's just costly to hire labor, the demand can be a barrier to adoption. Small scale farmers, particularly those in low income regions, may struggle to implement agroecological practices without significant training and support from the federal government. Additionally, many large scale farmers in developed countries may be resistant to change due to efforts required to transition away from conventional farming methods. So, even if the US does try to adopt this, farmers around the world may not actually model the United States on this one, and the United States may have trouble getting farmers to adopt it themselves. There's also the problem of transitioning to agroecological practices just costing a lot of money. Farmers may need to plant cover crops that they don't get any money off of, or establish an agroforestry system, or invest in soil restoration practices. And those investments could take years and years and years to pay off. Remember, the apple tree doesn't produce apples in the first year. As agroecology tends to focus on the long-term success, those short-term production goals and growth and economic costs could end up putting farmers out of business. For small scale farmers with limited financial resources, the initial costs really are prohibitive, and it's a barrier to entry into agroecology. Without financial support, without the incentives, it just can't happen. Next, there's the idea of an inconsistent result and a general risk within agroecological practices. Think about it. The results of agroecology are highly dependent on local environments and conditions like soil quality, climate, and the biodiversity created on agroecological farms. There needs to be a deep understanding of local ecosystems. That means practices that work, say, in West Texas won't work in Nebraska or Oklahoma necessarily. And that means that the farmers have to be highly specialized within their region. The variability between, say, the weather that I get in Colorado versus the weather that happens in, just west of us in Nebraska or in Kansas, just south in Nebraska, all can change how the growing season occurs in each of those regions, which are all very close to each other. And the practices that I have here in Colorado are not the same practices necessarily that will work best in Nebraska, Oklahoma, or Texas. So this variability can create a risk for farmers, especially those who are used to predictable yields, because one year I may be able to produce a lot of corn, but the next year my corn crop may not do very well. And so I have to have a ability to take on that risk of predictable yields versus the industrial agricultural system, which created predictable yields through monoculture systems. If farmers are unable to achieve the consistent results, they're probably going to be less likely to adapt agroecology on a wider scale because nobody likes to have their wallet unpredictably empty. So the unpredictable factors with climate change and just growth seasons can make agroecology very less appealing. Finally, one of the biggest challenges that agroecology has, and I've mentioned it multiple times, is scaling up to feed large populations. Agroecology is typically practiced on small scale to medium sized farms and is well suited for local food systems like farmers markets and stuff like that. But it may be difficult to scale these practices up to meet the needs of a densely populated urban area and global markets. Think about your local supermarket in, Houston or Dallas. They're not generally supplied by local produce. They usually get their produce within a global market, and that's how they keep their prices low. If you go to a farmer's market, that same head of lettuce that may cost you $2 at the grocery store is going to cost you $4 to $5 from your local farmer. And so that ability to have cheap food globally relies on the industrial agricultural system. And a transition to agroecology on a global scale would require just massive changes in land use, supply chains, consumer behavior, you name it, because the organic steak is going to be way more expensive than the steak that was produced at a CAFO. And while agroecology does offer many benefits, including sustainability, environmental stewardship, and some real social effects, it's important to recognize the challenges that it does present. Lower yields, labor demands, upfront costs, inconsistent results, and the difficulties of scaling up are all valid concerns. And for these reasons, some argue that agroecology is not a one-size-fits-all solution, and there may be ways to find a balance in strength in ways to balance its strengths with the efficiencies of industrial agriculture. And that could be the key to feeding the world and sustainability. Some of those people talk about introducing some agroecological practices while maintaining the use of fertilizers and pesticides. There's a talk of a green revolution 2.0, which increases the technological practices in agriculture to solve some of these problems with soil demands while still providing large-scale industrial agriculture. Ultimately, while industrial agriculture has played a crucial role in feeding the growing global population, it's increasingly clear that our current system is unsustainable in the long run. The environmental degradation, social inequalities, and economic risks associated with industrial agriculture demand that we start exploring some alternative to it. Agroecology offers a pathway forward. It respects the limits of our planet's ecosystem, and it supports small-scale farmers and builds resilience against climate change. But again, it's not without problems. We have the tools and knowledge to make shifts towards a more sustainable and just food system. One way may be embracing agroecology and its principles of ecological balance, diversity, and community empowerment. But there may be others, whether it's new fertilizers, new crop rotation techniques, new technology that introduces genetically modified crops that are more sustainable and more resilient. We can create a future where food is produced in better harmony with nature. It's really not a choice. It's a necessity. If we are to secure a livable planet for future generations, we must do something now to address the harms of our current agricultural system. But just what we do is going to be up to you and your debates. Thank you. Good luck, and check out the 2024 UIL Fall Champion Briefs Lincoln Douglas brief for evidence and information on these types of arguments and the stuff that I talked about today. Again, thank you for listening, and I hope you have a great fall season.